Hello and welcome to another Invalid video. So I'm just going to jump right into it and explain what a coroutine is and why coroutines can be very useful, along with some examples. So a coroutine is a special type of method that allows you to spread a task over several frames. It's different from a typical method. Usually when you call a method, it will run uninterrupted to completion, with all of the actions in that method occurring within a single frame update. That rapid execution time is obviously very useful, but sometimes you want to sequence events over time. For that we have coroutines. So to illustrate the difference between a method and a coroutine, I'm going to create a simple procedural fade animation. Okay, so I've created a new Unity 2D project. So first I'm going to create a new script called testing. This will house our fade animation. Next I'm going to add a sprite to my scene, then I'll attach the testing script to my sprite. So let's look what happens if the fade animation is in a normal method. Here we have a reference to the sprite renderer and we're using it to get the sprite's color. Then in our for loop, if the sprite's alpha value is greater than 0, we decrease the alpha value by 0.1. This loop will iterate 10 times and our fade method is being called from start. So if we run this now, you can see that the sprite has changed from visible to invisible in an instant. To make that fading visible, we have to reduce the alpha of the fade over a sequence of frames. That way we can display the intermediate values that Unity renders. Here everything is happening instantly and those intermediate values are never being displayed. So to create a coroutine, we have to declare it with an IEnumerator return type, and we also need to include a yield return statement somewhere in the body. In this case, we need to put it in our loop. This is because the yield return null line is the point at which the execution of the method is paused and then resumed in the next frame, meaning the loop will iterate each frame instead of just one. But to run the coroutine, we need to use the start coroutine function, passing an IEnumerator method in as a parameter. So if we play the animation now, our method will run across 10 frames instead of 1, as our loop will iterate 10 times. However, the fade out will happen very quickly. This is because our modern computers are exceedingly quick. So if we assume our FPS is around 60, then the animation will take place in only 166 milliseconds. So instead of waiting for the next frame, we can wait for an amount of time. So to do this, we just return a new instance of wait for seconds, and in the parameter pass in an amount of time we want to wait for. Here we've told it to suspend the coroutine for a quarter of a second. If we run this now, we can see our fade out animation. So that was just one example. There are many other ways you could utilize coroutines. If you saw my previous video, you'll know that I used a coroutine to move the snake in my scene. Here it's essentially replacing the job of the update loop. The advantage with coroutines is that it's being called far less frequently than update, and thus reducing the amount of overhead for our scene. It's also a cleaner implementation. This is an example of how the move method could be done using an update loop. Here we have to count the time between each frame, then check if enough time has elapsed before moving the snake. This process then repeats. If we assume our program runs at 60 FPS and that the movement occurs every 1 second, then we have to make 60 calls to the update move method before the snake moves, versus a single call with our coroutine. Okay, so that was a quick look at coroutines. Thank you for watching. If you'd like to know more, the Unity documentation is a great resource. I use it to create this tutorial, and if you enjoyed the video, please consider subscribing. See you next time.